Hello and welcome back, problem solvers. Today we're going to continue with, you guessed it, Chapter 7, doing some more sub-problems. Buckle up. Here we go. This is a problem that's like a mixture problem. We're going to see a few of these coming up here the next couple days. So I think this one is a really good one to help kind of start us in thinking about how to work with these types of problems. So let's say I have a mixture, a paint mixture, that is 25% red paint, 30% yellow paint, and 45% white paint. That would make some sort of light orange maybe or something. But anyways, if 4 quarts of red paint are added to 20 quarts of this mixture, what is the percentage of red paint in the new mixture? So basically I take 20 quarts of this mixture right here and I add more red to it. So basically I'm taking that lightish orange mixture and I'm making it more red by just adding 4 quarts of red paint. So I want to figure out what is the percentage of red paint in this new mixture. So let's take a look at some sub-problems. First thing I'm going to start with, how many total quarts of mixture do we start with? That's given to us right here in the problem. 20. That's it. Then what I want to do is I want to figure out how much of that is red paint. So we know that it's 25% red paint. So what I'm going to do is figure out how many quarts of red paint that is by doing 25% of 20. So it's 5 quarts of red paint. So we're starting with 20 quarts of mixture. Of that mixture, 5 quarts of that are red. Next, after adding more paint, how many quarts of the new mixture are there? So basically it used to be a mixture that was 20 quarts. I just added 4 quarts of paint to it. So now I've got a total of 20 plus 4, 24 quarts of my mixture. Next, I want to know how much of that 24 quarts is red. So I used to have 5 quarts of red. I just added 4 more quarts of red paint for a total of 9 quarts of red. And then finally, what percent of the new mixture is red? So of these 24 quarts of paint mixture, 9 of those quarts are red paint. So it's just simply 9 out of 24, which, use your calculator, that's 37.5%. All right. Next, we're going to do a mixture problem that will actually require us to combine 2 problem-solving strategies. We're going to use basically this similar sub-problem strategy, but we're also going to be having to do some guess and check. So here we go. Frosty is trying to make chocolate milk for Santa. So far, he has made a 10% chocolate milk solution. That means the solution is 10% chocolate combined with 90% milk. He has also made a 25% chocolate milk solution. Unfortunately, the 10% solution is too weak and the 25% is way too chocolatey. Now, he has a whole bunch of the 10% solution, as much as he wants, but he only has 30 gallons of the 25% solution. So how many gallons of the 10% solution should he add to the 25% solution to make a mixture that is 15% chocolate? Because he's sure that a 15% solution will be perfect. So basically he's got 30 gallons of this stuff that's too strong. So he's gonna combine some weaker stuff with it until it is just right. Now, to do this problem, we are basically going to use these almost exact same sub-steps, okay, or sub-problems. However, we have to do these sub-problems for a guess. And then we look at our result and then we adjust our guess. So we use guess and check. So basically, the sub-problems that you would do become the headings of a table. So I'm going to start by listing what I know about the 25% mix, how much I have, and how much of it is chocolate. I'm then going to guess a number for this right here of how much 10% mix should I add, figure out how much of that is chocolate. Then I figure out how much total chocolate milks I have then after combining this with this. And then I also figure out how much total of it is chocolate by combining this number with this number. I then find the percentage of this new mixture that is chocolate, and I'm hoping to get a 15%. So here's what that looks like. I start with 30 gallons of 25% because it says right here, I will have 30 gallons of 25% solution. That number is not going to change. That's going to be the same for every one of my guesses. Then I want to figure out how much of that is chocolate. Well, 25% of it is chocolate, so 25% of 30 is 7.5. This number will also not change. This will be the same for every one of my guesses. I then just take a guess. How much of this weaker solution should I add to this? And I just guessed 10 because I often just start with 10 as my first guess. Now, of that 10 that I'm adding, 10% of it is chocolate, so 10% of 10 is 1. So that's how I got that number. I then basically combine these two together. So 30 plus 10 gives me 40 total now gallons of this new chocolate milk mixture. Now, how much of that is actually chocolate? Well, 7.5 gallons of chocolate came from this, and 1 gallon of chocolate comes from this, for a total of 8.5 gallons of chocolate. Then I calculate that as a percent, 8.5 divided by 40, to get that it is now 21.25% chocolate, which it started at 25%, so I have reduced it. It is now less chocolatey. However, it is still not quite down to 15%, which is what I want, so this is too high. So since that's too high, I changed my guess to something else, and I guessed 5. Okay, so notice these two numbers stayed the same because I'm not changing how much of this I have. I always start with 30 gallons of this, which is, 30 gallons of mixture and 7.5 gallons of chocolate in that 30 gallons of mixture. And then I'm going to add 5 gallons of 10% mix for a total of 35 gallons of mixture total, 30 plus 5. Then I do 10% of 5 is 0.5, that's half a gallon of chocolate added to this 7.5 gallons of chocolate for a total of 8 gallons of chocolate. And then 8 out of 35 is 22.9%. Uh-oh, that's even higher. Oh no, I went the wrong way, which means I made my guess smaller because this was too high right here, but that actually makes the percentage higher. So I actually need to change my guess the other way. Oops. Well, I guess I learned something. The answer is more than 10, not less than 10. Okay, let's try another guess. I went with 20. So again, these numbers are the same. 10% of 20 is 2, so 2 gallons of chocolate in that 20 gallons of mixture that I'm adding. 30 plus 20 is 50. 7.5 plus 2 is 9.5. And then 9.5 out of 50 is 19%. That's still too high. And if you compare it to, our first guess, I didn't change it by a whole lot, by a couple percent only. I want to get down to 15%. So what I'm going to do is I'm going to change my guess by a whole lot this time. I'm going to go all the way up to 100. So again, these two are the same. Here's 10% of 100 is 10. Then here is 100 plus 30 is 130. And then 10 plus 7.5 is 17.5. And 17.5 out of 130 is 13.5. And this is now too low. I'm shooting for 15%. But if you compare, like even this guess to this guess, this one's closer to 15 than this is. So I guess my answer is probably going to be, or I guess comparing these two, my answer is probably going to be closer to 100 than it is to 20 because this is closer to 15. But I'm going to make a guess that's, in between 20 and 100 now. And I'm going to go with 70. So again, these two are the same. 10% of 70 is 7. And then 70 plus 30 is 100. 7 plus 7.5 is 14.5. And 14.5 out of 100 is 14.5%. That's a little too low, but really close. I'm only off by half a percentage, so I'm getting pretty close. But it's still too low, so I'm going to make my my guess a little lower, and that will increase the percentage. And hey, look at that. When I guess 60, 10% of 60 is 6. And then add together the mixture, this 60 gallons of mixture with this 30 gallons of mixture to get 90 gallons of mixture. 6 gallons of chocolate plus 7.5 gallons of chocolate to get a total of 13.5 gallons of chocolate. And 13.5 out of 90 is exactly 15%. So I have finally nailed the correct answer. However, make sure you go back and read the question. How many gallons of the 10% solution should he add? Gallons of 10% is that first red column there. So this is the number I'm looking for. I'm looking for this answer of 60 gallons. So be careful to read the question, because I might have asked how much total does he have in the end, and he has a total of 90 gallons of this mixture by taking 30 gallons of the 25% and adding to it 60 gallons of the 10% solution. He was able to create 90 gallons of a 15% solution, but my answer here is 60 gallons. All right. So that is a type of mixture problem that is a little complicated. For your homework, neither one of these is a mixture problem yet, but I will give you a heads up that in future homework assignments we will have a few of those mixture problems, and we will go over another one of those tomorrow as well. But for now, for these two homework assignments, make sure you're listening and solving subproblems, like I demonstrated here. Your question and your answer, your question, then your answer, and so on. Make sure you're using that strategy to do both of these problems for your homework tonight.